Good morning, class. So today we'll go through a new physics topic. But before that, I want to recap of what we have learned last lesson. Let's just go through a short recap. So now the first question is, what is energy? Okay, we did discuss about this last lesson. So can someone tell me, Kenneth, what did we discuss? Energy is?
Energy is power.
Power. Okay, Alan?
Energy is work.
Okay, how about Willie?
Energy got something to do with power.
Okay, remember, energy is the ability to do work. Okay? Very good. Yes, you got the word correct. But then remember, it's the ability to do work. Okay? So, now, what are the types of energy that we discussed last lesson? So now we're going to play a small a game. I'm going to show you pictures of energy, then you'll just think about it, and I'll ask you what energy it is, okay? Let's just, okay, so, okay, sorry. Okay, so now, can you tell me what energy is being involved in this picture? Xiaofei? Very good. Okay, as you can see, kinetic energy, this ball is having a movement, right? So kinetic energy is energy related to what? The speed. Yes, the movement of an object. Very good. Okay, now, as compared to these two masses, okay, what energy does this vase possess? Jimmy? The one on the right.
Potential energy.
Very good. Okay, so we also know that potential energy is basically energy related to the position of the object, right? With reference with the height from the reference line. Okay, how about this? What energy is this? Kenna?
Chemical.
Yep, chemical. Very good. This? Alan?
Nuclear energy.
Yes, nuclear energy. This is a nuclear reactor. Very good. How about this? Willie?
Solar.
Close enough.
Wind. Palm oil.
Xiaofei? Yes, it's light energy. Okay?
Solar what? Oh, solar.
Yes, you can say it's solar also. I'm not saying it's okay. This is solar. Yes. What other type of energy is this? Starts with T.
Thermal.
Yes, thermal and solar. Very good. Okay. This. How about this? Okay.
Electricity.
Yes, electrical energy. Okay. So these are the few types of energy that we went through last lesson. So now today we will talk mainly about two energy. So these two energies. Why do we gravitational potential energy and also kinetic energy? Okay. Why do we discuss about these two? Is because these two energies are what we call the mechanical energy, which is it consists most of the type of energy that we deal with in our everyday life. Okay. So today's lesson, right? So before we move on to today's lesson, I want to recap with you the formula of kinetic energy. So you all should remember that the formula of Ke is given by half mv squared, right? M is the mass of the object and v is the speed of the object. And as for potential energy, you have the formula of GPE, which is equal to mgh, where m is the mass of the object, G is the gravitational acceleration, h is the vertical height of the object from the reference line. Now, today's lesson's objective. Today we will cover the idea of the principle of conservation energy. Okay? So now, come. Look in front here. So now here I have an egg, okay? Here I have an egg. So this is a very heavy pendulum, right? You see? It's quite hard, right? So it's able, I think it's able to smash through the what do you call it? The egg shell. Okay? So now, when I'm gonna release this pendulum from the surface of this egg. Okay? As the pendulum gonna swing there and swing it back. How many of you think that it will hit or smash the egg? Can you raise up your hand? Really? Very good. How about the rest? How many of you think that it won't smash? 2, 3, 4. Okay, how about Kenneth?
Don't know.
Okay, can. So I want you to have okay, so I already have an idea, okay? So I'm going to release, at the moment I'm going to release this pendulum and then you will answer some of your questions and doubts. So let's just see. Okay? You see that? Okay, you want to see again? Okay. Okay? Okay, I'm going to just leave it, okay? I'm not going to catch it. Okay? Okay, so you realize that the pendulum didn't actually break couldn't like break the egg, right? Couldn't like come back and hit the egg. So now today's lesson, right, we will talk about the principle of conservation of energy. We'll use this principle and try to explain the phenomenon of this egg. Okay? Like why the pendulum didn't hit the egg. Okay? So now before we move into the next activity, I'm going to introduce to you this principle called the principle of conservation of energy. Now this principle states that energy cannot be destroyed or created. It can only be converted or rather transformed from one form to another. And the total energy in an isolated system is conserved. Okay? Just take note of these few highlighted as keywords. The energy cannot be destroyed or created. It can only be converted from one form to another. Okay? Okay? Okay. So this pendulum movement, right, can be modeled by this movement of this skater boy. Okay? And this this movement of the skater boy is actually pretty much similar with the movement of the pendulum. So before we begin, I'll roughly explain to you what is this about. Okay. Before we start, I think we start first. Okay, now. Okay, I know like most of you will be very familiar with them. Like with skate parks and stuff, right? So before we start, you look at as you could see, this is a ramp and this is a skater board, and this is what we call the PE potential line, right? The point of reference. So this point of reference can be moved up or down. Okay? So now, and as I release, yeah, this is the movement of the skater boy. Okay? What other stuff that we have? Yeah, I think that's all. So this is a track. Okay? Now, the PE point of reference will be at the bottom. For simplicity's sake, we just put it at the bottom of the ramp. Okay? Okay. Now, talk about, so just now we did mention about the formula of KE and PE, right? KE is given by half mv squared, and PE is given by mgh, right? Take note that KE is dependent on the mass and also the speed of the object, whereas GPE is what? Is affected by The mass, height, and also the gravitational acceleration. Correct? Okay. So now back to this skater boy. So with that, okay, now we talk about KE first. So let's talk about the KE. So as you see this skater boy swinging from left to right and right to left and to the bottom, at which point do you think that the speed of the skater boy is highest at its max?
The speed.
Yeah, the speed. Any idea? Bottom. Okay. Everybody, Jimmy? What do you think?
Bottom.
Bottom. This point, right? Right? Very good. Now, so at this point, you all agree that it's moving at the faster speed. Okay. Now, the next question is, if this have a higher speed, right? So what can we conclude? Which energy is highest? Which energy is at its max? Kinetic energy or potential energy? Kinetic. Why?
Faster speed.
Yes, just now we mentioned, right? It's the fastest. Very good. Then how about the potential energy at this point here? At this lowest point?
Zero.
Zero. Why is it zero? Yes, very good. So we have 1 rand. So we say that here V is max, right? V is the fastest. Hence KE is max. Right? And since H here, point of reference is here, H is zero. So GP is given by MGH, right? Which is MG
Zero.
which will yield
Zero.
very good. Okay? Okay. Now the next question will be at which point then now you say that the potential energy here is zero, right? It's at its minimum, right? So then at which point is where the maximum potential energy occurs? Which point? Xiaofei? Yeah, maximum potential energy. The two ends here. Do you agree, class? Why? Really, can you explain to me why do you agree with that statement?
Because with respect to the reference point is the highest.
Very good. This is the highest. Okay? This is the highest. Now, at these 2 points here, right? You also notice what? What do you notice? What is the speed at this point?
Zero.
Zero, right? We say that it is momentarily at rest because the skater boy goes up and at this point it stops momentarily and changes direction. So V here is zero. Very good. Now, you say that H here is H max, right? This point here. Okay, I read it. I will use another marker to. Now we look at this point here first. It's actually the same. So H here, H max, right? Hence this will give us GPE max. Correct? And you also notice that the velocity, the speed of the skater board at this point is given by 0, right? Hence KE is 0. Okay, very good. Now, very good. Okay, so I'm gonna introduce a graph bar to you and let you see, okay, at these 2 points. Now, with respect to the principle that we just read just now, principle of conservation of energy, that energy cannot be destroyed nor created. Okay? And it can be converted one to another. The total energy is in an SI system is conserved. Okay? Now I'll try to explain why. Okay. Okay. So this energy bar graph, right? As you see this skater boy, at any given moment, you will have your kinetic energy and potential energy being calculated from this bar graph. Okay? So as you could see, just now as you mentioned, right, you do agree that at the bottom, your at the bottom, you look at this point here. The kinetic energy here is at its max, right? and the potential energy is at its mean. But it's supposed to show. Okay. Okay, as you could see, right? Okay, could you all just ignore the thermal energy because we're not taking into account of the frictional force, okay? The thermal energy actually accounts for the frictional force. So as this motion, you could see here, at this lowest point, what do you say about the speed? The Ke is at max, right? So can you see that this kinetic energy here is at its max, right? So now total energy is given by the total energy possessed by this skater boy. That is to say the Ke and the potential energy. Okay? So what can you deduce from here? The Ke is equals to the total energy. Right? So from at the max, at the highest peak, you have your potential energy equals to your K total energy as well. Your potential energy equals to Ke. So at any given point, your Ke and potential energy, as you could see, this chunk here, if you were to move up here, it will give you the total length. Okay? Hence, this can conclude that our total energy is given by Ke plus GPE. Okay? This is the building block of the principle. Understand? Okay. I think that. So in the next lesson, the